Hello everyone. Let us start with some illustrations on fundamental principles. Fundamental principles of counting we have already done in our previous session, and which all principles we had done. One was multiplication principle, second was addition principle, and third one was bijection principle. All three of them actually go hand in hand. I mean, at times you do not know that question is straight away from multiplication principle or straight away from addition principle. It could be combination also. Frankly speaking, there is no particular language also which will tell that question is from which particular part. For example, here I write my first illustration as the number of positive integral divisors of 2 raised to 5, 3 raised to 4 and 5 raised to 3. This is the number. Now, instead of giving you number, I have already given it in the factorial form. I have number as 2 raised to 5, 3 raised to 4, 5 cube. That is the number. And question is regarding find the positive integral divisors of this number. And 4 options are given. Obviously, we have to pick up the correct one. Now, question doesn't give you any hint from where we have to start. Be little alert and start thinking that what a divisor would mean here. That divisor would have perhaps some power of 2, some power of 5, some power of 3, something like that is expected in that divisor. So first I try to write any divisor would be of the form. Now what type of form we are expecting? It has to be of the form 2 raised to something, 3 raised to something, 5 raised to something. That something I am writing as 2 raised to A, 3 raised to B and 5 raised to C. Correct? Now A can take which all values? Obviously, most of you would say, of course, it would take values from 1 to 5. Why I am writing there 0 also? Because if there is no power of 2 involved and only powers of 3 or powers of 5 are involved, suppose, still that number remains a divisor, correct? So even 0 can be a candidate for A. Similarly, 0 can be candidate for B and C also, correct? And B takes values from where to where? B takes values from 0 to, yes, it will go up to 4. And for C, what are the options? 0, 1, 2, 3. Correct? Now, once you choose A, B, C, your job is done. Correct? So, use multiplication principle and tell that how many divisors are there. Using multiplication principle, divisors number would be finally 6 into 5 into 4. I hope you have understood why I am saying 6 into 5 into 4. A can be chosen in 6 ways, means options for A, 6 available. So, A's place can be filled in 6 ways. B's place can be filled in 5 ways and C's place can be filled in 4 ways, correct? So finally my answer should be nothing but 120. I hope this is clear. This was just straight away almost actually application of multiplication principle. But when you read the wording, actually you do not get any hint that why multiplication principle or which principle rather. Okay, so let's move from here to the second question. Before that, don't forget to mark. Correct option is C. Now I go to second one, and second one is the number of positive integers up to 9 digits in which the digit 1 appears at least once is, and again I am given 4 options. Now question says number of positive integers, means nowhere all the places zeros allowed. I hope you followed, means 0 is not included. And question is regarding number up to 9 digits. That number what you are going to choose can be up to 9 digits, means 1 digit, 2 digit, 3 digit, all numbers are possible. Up to 9 digits you are allowed to take. Fine. And which all are the options for filling those places? 0 to 9. 0, 1, 2, 3 up to 9. Correct? So, if I am asked to find out number of positive integers up to 9 digits, then first I try to find out only number of numbers up to 9 digits. That would be 10 raised to 9. Why do I say so? 10 raised to 9 because each place can be filled in 10 ways. So use multiplication principle. 9 places are there. So 10 raised to 9. Correct? And similarly, I can go for numbers in which 1 is not involved anywhere. So that would be 9 raised to 9. Again, same logic. Excluding 1, rest all 9 digits are available for filling those 9 places. So 9 raised to 9. Correct? And then I go for required number. And I am asked to find out required number. Required number would be what? That total number, which is 10 raised to 9, correct? Minus something we are expecting, correct? What number we will be subtracting? Perhaps 9 raised to 9. That we will be doing. But then actually what we do is 10 raised to 9 minus 1 minus 9 raised to 9 minus 1. Why am I doing so? It is only for you to understand that 10 raised to 9 minus 1, that minus 1 I am writing because if all 9 places were filled by zeros only, then you would have got a number 0, which is not a positive number. And same is the case with 9 raised to 9 minus 1 also. There also I subtract minus 1. Reason is, yes, again 0 would be involved. 0 means entire, all 9 places filled by 0. Even that is to be rejected. So 10 raised to 9 minus 1 minus 9 raised to 9 minus 1. So final answer has to be 10 raised to 9 minus 9 raised to 9, and hence the correct option is B. Correct? So let us move from here to the next one. And the next one is that a sequence is a ternary sequence if it contains only the digits 0, 1, 2. Like binary sequence, where there we had 0 and 1. Ternary sequence is a sequence where 0, 1, 2 are involved. The total number of ternary sequences of length 9, which either begin with 2, 1, 0 or end with 2, 1, 0 is, and then 4 options are given to me. So let us start with the solution. Now, there are 9 places. Each place can be filled in 3 ways. And question says that it has to begin with 2, 1, 0 or it has to end with 2, 1, 0. So first I find those sequences where it starts with suppose 2, 1, 0. Now first 3 places have already gone. Now rest 6 places are there. All those 6 places can be filled by 3 numbers, means either 0, 1 or 2. So 3 options are available for each of remaining 6 places, correct? So sequences which start with 2, 1, 0, their number would be 3 raised to 6. Why I am saying 3 raised to 6? Each place can be filled of 6 remaining places by any of those 3 options available, correct? And numbers ending with 2, 1, 0 or sequences ending with 2, 1, 0, again similar logic. Last 3 places would be filled by 2, 1, 0. First 6 places are available. Each place can be filled in 3 ways, 0, 1 or 2. So their number also would be 3 raised to 6, correct? And actual number where we want is starting with 2, 1, 0 or ending with 2, 1, 0. Mind you please, there could be some numbers which start with 2, 1, 0 and end with 2, 1, 0 also. They actually also may satisfy the condition. So their number also we try to find out. First 3 places have gone with 2, 1, 0. Last 3 places also have gone by those 2, 1, 0. Only middle 3 places are left, and their number would be now of such sequences I am saying, that would be again 3 raised to 3. So go for required number. Can you recall? Number of A union B is NA plus NB minus NA intersection B. Here my set A would be where sequences start with 2, 1, 0. Set B could be sequences end with 2, 1, 0. And A intersection B would be starting with 2, 1, 0 and ending with 2, 1, 0 type of sequences. So the required number would be 3 raised to 6 plus 3 raised to 6 minus 3 raised to 3. So on simplification, that would turn out to be nothing but 1431. So my correct option is B. Okay. So this was actually not straight away application of multiplication theorem, but certainly we have used here addition principle. Here our A intersection B is not 5. For addition principle, we need A intersection B to be 5, but we have used part of set theory and finally we have got our answer as 1431. So let us move from here to the next one. And the next one is, consider lines x equal to k and y equal to k. K varies from 1 to 9. The number of non-congruent rectangles whose sides are along these lines is, and then some 4 options are given as usual. And we have to pick up the correct one. From where we have to start? Mostly you would try to draw the picture. So I have drawn the picture here. Okay. So I draw y equal to 1, y equal to 2, etc. up to y equal to 9. And then I have drawn x equal to 1, x equal to 2, etc. up to x equal to 9. And then I go for actually counting rectangles. See, the entire chapter, I would say, is of systematic counting. I mean, don't count randomly here, just because the picture is ready in front of you. What we do is, we go for actually the rectangles which are between y equal to 1 and y equal to 2. Okay, so think of different lengths now. Now width is fixed between y equal to 1 and y equal to 2. So what type of rectangles you are expecting? One could be of size 1 by 1, means length, breadth both 1. then breadth still 1 and length 2, something like that we can have. So 1 by 1, 1 by 2, 1 by 3, like that up to 1 by 8. So 8 rectangles could be horizontally placed, right, between y equal to 1 and y equal to 2. Now I go for the next, and then I check between y equal to 1 and y equal to 3. Between these two lines, how many rectangles we can have? Mind you, please, we start that number with 2 by 2. We do not count rectangles of size 2 by 1. Why do we do so? Look at the question at the top. Question says we need non-congruent rectangle. Non-congruent means size 1 by 2 and 2 by 1 if you have. They are not non-congruent, they are congruent. You can actually put a rectangle of size 2 by 1 over a rectangle which is of size 1 by 2, and one would overlap other. So they are actually congruent rectangles. So size 1 by 2 if I have covered in the previous statement, then now my counting will start from 2 by 2. So 2 by 2, 2 by 3 up to what I can go? I can go up to 2 by 8. So such rectangles I find, and they are 7 in number. Continue this way. So you will finally go from y equal to 1 to y equal to 9. Now lastly, okay. So how many rectangles you can have here? And there would be only one rectangle of size 8 by 8. 8 by 1, 8 by 2, again on the previous logic only, we are not going to consider. So only one such rectangle you can have. So total number would be actually starting, I mean from the top, that 8 plus 7 plus 6 and so on up to 1. So final answer would be nothing but 36. How you simplify that choice I am leaving to you. I have used here a formula which is actually given in arithmetic progression. You can simply add all of them. Number is not that big. You can actually add right from 8 to 1. 8 plus 7 plus 6, etc. Final answer is important, and answer is 36. So my correct option is D. So here I end my session. Next time when I come, again I will get something new. Hope you have enjoyed the session. If you have liked the video, please click on this side. And if you want to place an order for the book, click on this side. Thank you.